Hello everybody, my name is Mahmoud Hisham. I'm working in EMC Egypt as a system engineer responsible for the public sector and the financial services. We'll be talking with you very shortly for the next couple of minutes about the flash technology, its evolution, and the different kind of generations of flash, how it's been evolving, and how it affects the enterprise. Now, let's start with the Gen 1. With the Gen 1, before Gen 1, there was no flash in the enterprise storage arrays, the traditional external disk storage subsystems. The flash technology was a little bit fancy thing to adopt in such systems, and it was a little bit costly to put the volumes on flash. So with the Gen 1, most of the storage vendors started to incorporate flash technology within the traditional external disk storage arrays, which was a little, let's say, sexy thing to do with the enterprise disk subsystems, because Flash formerly was a little bit costly to adopt, and it was too difficult to be integrated within the traditional storage arrays. So with the Gen 1, most of the storage vendors started to adopt flash technology within as a standard tier within their available disk tiers inside the array, promoting to the customer the feature to have part of their workloads, specifically the mission critical workloads, being hosted on that flash tier to be to be served uh, uh, um, for um, for the maximum IOPS that most of the mission critical applications demand, and with the extremely low latency or access time that the flash tier can provide to the mission critical applications. So with that time, the flash was a little bit sexy thing. It was so costly, it was too good to be true, but the storage vendors started to adopt that by providing flash as one of the available disk tiers within the storage arrays, without having any kind of data services, without being integrated with any kind of functions within the storage itself, the data protection, the efficiency, the replication, whatsoever. And also, it was a little bit costly to put everything on flash by that time, so customers have to compromise between space efficiency, data services, and performance for a selective set of workloads that will get the maximum benefit out of the flash. So let's talk about Gen 2. Afterwards, storage technology, storage vendors started to think in a different way, which is to maximize the utilization of the flash within the storage, within the data center itself, while at the same time keeping an eye on the cost factor that the flash will add to the entire storage array investment. So for that time, the flash technology started, or let's say the flash economics started to fall down. And at the same time, most of the storage companies started to think out of the box to maximize the utilization of the flash to cover more kind of workloads, not only for the mission critical workloads and tier 1 applications, but can also be stretched to absorb other type of workloads like tier 2 applications without increasing the cost of adopting the flash itself. So for having such kind of, let's say, performance economics balance using the flash as a tier of the traditional storage arrays, there has to have a kind of data services and what's called automatic tiering to auto tier the data, the hotspots of the data on the flash, and also between the flash and the magnetic disk drives. So, for instance, instead of just putting all of your volume data on the flash statically, you can just put the hotspots, continuously monitor and assess your volume data, workload, and migrate the most frequently blocks and chunks of data to the highest speed medium, which is the flash tier. Uh, by having that said, it means that we can better utilize the flash technology to serve more hotspots and to serve more I/O demands than before. So instead of just consuming the flash for the entire volume, which was not necessarily be that demanding to the I/O or the latency requirements, we can just migrate the hotspots, the most frequently accessed blocks and chunks of data, to the flash, getting the tier 1 performance from the flash, the maximum IOPS, the low latency requirements, whatever, and at the same time freeing some space of the flash itself to accommodate more kind of workloads, more type of workloads, and more volumes. So with such kind of feature, it enabled lots of workloads to be consolidated on a hybrid storage tiers. Hybrid storage tiers, it means that you can have more than one tier. It's all fully integrated, continuously monitored, where data is always auto-balanced across those tiers, which is according to the workload profile it has on a continuous manner. So, for instance, we can just put now tier 2 workloads on a hybrid storage tiers, which is flash and magnetic disk drives, and instead of just having all the mission critical applications being occupying the flash tier solely, without any chance for tier 2 applications to get the benefit of the flash itself. So it was a little bit, let's say, a workaround to try to maximize the utilization of the flash within the data center for most of the applications, not only tier 1, but we're talking also about the tier 2 applications that can also benefit from the flash technology and its high performance profile. So till now, we still didn't promote any kind of data services. The storage technologies out there didn't have the capability to integrate most of the data services that we know, like encryption, compression, deduplication, replication within the flash tier itself. So it was a little bit cumbersome, a little bit challenge to have those features enabled while having the auto-tiering features also enabled to maximize the benefit and utilization of the flash itself across the storage array footprint. So you still had to compromise between, let's say, the performance and efficiency, along with the data services and data protection. So it wasn't that good by that time, but it was okay. It was, let's say, it was a good to be true at the beginning solution, considering the flash economics, which was a little bit higher than the affordable levels. With that tiering, it was a little bit appealing to maximize the benefit of the flash and to reduce the TCO of having a flash within your data center serving most of the workloads. So now let's start with the generation 3. The Gen 3 flash, it started by having all what's called all flash array. The all flash array, or the term AFA, it means that the storage controllers and the storage boxes started to, let's say, being designed from the ground up in order to serve a flash medium. So when we have a look around the flash economics after the past decades, it has been dropping so down. The cost started to be at reasonable levels, at affordable levels, and this makes the storage companies rethink and redefine the flash strategy. Having that said, most of the storage companies started to promote the idea of having an all-flash array. All-flash array, it means that the storage controllers, it's been designed from the ground up to serve flash workloads for optimizing the carry out of the flash functions, the commonly known flash functions like over provisioning, query leveling, everything, just out of the box without adding any more latency or overhead to the performance, and at the same time integrating this performance benefits, this low latency benefits with the mostly known data services in the market, like data protection, encryption, replication, etc. So now with the Gen 3, we have almost everything. We have the flash technology at high performance, extremely low latency. We can just say 100,000 IOPS, sub-millisecond latency, and at very consistent and sustained rate without impacting the performance. And at the same time, we still don't have to compromise the data services, some of which are very important, like snapshot protection, replication, encryption, and also for we have seen some storage vendors promoting space efficiency on the flash to drop the total cost of ownership of adopting the flash even much further by promoting compression and deduplication to the data being written on the flash. So now we have almost everything. We have all the data services around space efficiency, protection, security, everything. And also we have tier 1 performance for all kind of workloads, all kind of databases, all kind of instances, snapshot clones, everything. We have everything in a single array that's called all flash array. It's been designed from the ground up to serve flash workloads. It has all what it takes to optimize the flash performance and also to optimize the flash capacity itself, making it more sexy, more appealing, more affordable for most of businesses to acquire flash. So with Gen 3, now our dream came true. But still, there is something missing. What is missing about the flash technology Gen 3? There is a big challenge about the flash technology Gen 3, which is by having the cost of the flash being dropped year over year, most of the storage companies will start to, let's say, push with the flash strategy, push for their flash products to sell. Most of the customers will start to acquire that as a de facto standard for the data center and for the storage infrastructure. But still, there is a challenge. The challenge it's about the architecture. The challenge it's about scalability. The challenge is about mega scale environment, hybrid cloud environment, data lake solutions. We still can have a challenge about how the environment would scale. So with that sense, with the same sense, the traditional external storage arrays have been evolving since decades. The same thing is happening, exactly the same, to the flash technology itself. So let's say after reaching a very satisfactory level for when it comes to flash performance at sustained rate, flash capacity, and also flash economics, flash data services, everything with the all flash array, we still have some challenges about the scalability. How could we scale the flash technology within our data center? How can we have a high-end like architecture, multi-controller architecture with global cache across multiple engines, or what we call storage directors, serving the same flash workload? This is a big challenge for most of the businesses. There is a very wide concern about this point when consolidating and migrating the workloads from the traditional storage arrays to the too good to be true all flash arrays. We still have this challenge, a challenge about scaling out the capacity, scaling out the performance, while keeping the same level of the data services, while keeping the same level of integration with the other ecosystem in the data center, other third-party software, and also the different applications. We still have a challenge about that. So this is what Gen 4 is coming here to solve. The Gen 4 technology, it's about flash, sustained flash performance, optimized flash capacity, integrated data services that is always on at scale. That's the key word about the Gen 4. Gen 4, it's about scalability. Gen 4, it's about architecture that has been redefined in order to accommodate for more kind of workloads, to scale by time, non-disruptively, to have a multi-controller architecture that is high-end inherited and inspired from the traditional high-end storage arrays, being implemented there along with all of the sexy features we have been talking about in the flash. So, for instance, to have an analogy here about the comparison between the Gen 3 and the Gen 4, which is the latest we have right now. Let's say we have a Cristiano Ronaldo in a Real Madrid game, or let's say playing for his national team. So if we have Cristiano Ronaldo, we have everything actually. You have the agility, you have the power, you have the performance, you have everything at sustained rate, you have everything. And this guy is like, I don't know, it's like magic. He never get injured, he never had a bad game. However, how would you do if you do have like 5, 6 to 8 Cristiano Ronaldo in your team being played all together with for the same role, the same objectives, you never have a single point of failure because you will not be relying on a single player there. You will always have a maximum performance. You will always have the maximum efficiency. You will always have the maximum shooting power at scale. And you will never have a bad game. Never. Never have a squad that is that is having hard times out there because you can scale. You can scale your own best competencies in the data center to make it scale to serve your mission critical applications and others all at scale without any concern, without any worries about downtime, about scalability, complexity to manage, data coherency across storages. It's all the same because you have a multi-controller storage arrays, you have you can scale capacity along with performance while keeping the same reliability factors, the same data services being always on, always populated across all data stored on that all-flash array. And at the same time, you can scale to number of controllers that have never been reached before in the high-end market segment. So, as a summary to what has been said so far, Gen 4 flash technology is what the enterprises need at the moment. It's like a too good to be true thing at scale. This is a key word that everyone has to keep when it comes to selecting flash products. They have to be concerned about its scalability, how it's being scaling performance along with capacity consistently without compromising any kind of data services, without compromising any kind of integration to other data center components and to different business applications. So what you guys need right now is to go to Gen 4 architecture, looking after scalability, having all the flash sexy thing about performance, space efficiency, data protection, everything being there at scale to never worry about your data center performance, your application performance, your data center reliability, whatever. It's there. It will always work. It's always on for all kind of data services because instead of just having one Cristiano Ronaldo running into your data center so fast, so efficiently, you can just have multiple Cristiano Ronaldo, 8 Cristiano Ronaldos, all working together for the same goal, scoring the same goal, running fast, and you never have a bad day, and your team out there will never have hard times. You will never lose with the Gen 4 technology. Thank you so much, and please stay tuned for the comment. Thank you.